Hey guys, Buildzoid here, and today we're going to be doing some more LN2 overclocking with the 12600KF. This time it's just for fun. I'm not trying to get like high scores for hardware bot or anything like that. Basically, I was kind of wondering like, what's the lowest memory latency I can get in IDA or Intel memory latency checker with liquid nitrogen on the CPU and on the memory. So that's what we're going to do. I'm using the Gigabyte Z690 AOS Tachyon again, just because the board's already prepped for LN2. Also, I've run that board the most, so I don't really, I don't want to spend a lot of time on this, so I don't want to be using a motherboard where I still have to learn how it behaves, that kind of thing. Yeah, so we're not using a particular, today we're also not using, the operating system I used in the last LN2 video. That's an operating system I actually care about, so that one's actually good at things like, say, Cinebench and Geekbench, and it's not great at SuperPi, but it's better than this OS at SuperPi. So that's like an OS I kind of care about. Anyway, the point is that this OS is not going to be ideal, but yeah, I don't really care that much. So yeah. I'm not putting IDA on the other one. That's basically the logic behind why I'm using this one. Anyway, that's it. So right now we're just going to do like a baseline run with just XMP and 5 gigahertz on the CPU. So I'm going to pull up CPU-Z and memtweak it. Yeah, and I guess I'm going to cover up everything except the temperature readouts, because that's kind of the only thing that matters. So right now, again, I'm just using the Corsair memory kit. And the CPU's at 5 gigahertz, the ring is at 4.8. We're not going to be changing the ring clock, because I did notice that when you're on LN2, just mashing the ring clock massively boosts memory performance. 6 gigahertz ring is actually really fast. Same goes for the CPU frequency. I'm going to keep the CPU frequency and the ring frequency steady, and we're only going to fiddle with memory settings, because I think if you're I basically feel like it's cheating to just clock the CPU higher and then go hey, look, the latency's lower because the cores are faster and the ring is faster. Well, yes, that does lower the latency, but I don't think we're going to be seeing 6 gigahertz ring CPUs anytime soon, whereas we are going to be seeing stronger and stronger DDR5 kits, or at least hopefully we're going to be seeing stronger and stronger DDR5 memory kits over time. So anyway, yeah, that's it. Let's just get into it. So first IDA run, we're getting 66.4 nanoseconds of latency. And I don't know why I ran the whole benchmark. There wasn't really much point to that. I'm looking for a pen so that I can write this down. Man, imagine preparing yourself to make a video. It's like things that real YouTubers do. Okay, well, well, this'll work. Okay, so our first run is 66.4 nanoseconds of latency. Obviously, this is IDA. It's not super consistent. If we rerun the latency test, I imagine it'll go down. Assuming that we rerun it enough times, but honestly, it's going to stay in that sort of 66 nanoseconds range, probably. Yeah, actually, that was really... Okay, so actually, it's pretty consistent right now, 66.4 again. Anyway, let's run memory latency checker, close... No, I said close IDA, not minimize IDA. Oh, yeah, so 5 gigahertz, and then ring at 4.8. Anyway, we're going to do the latency test, which takes a while, unfortunately. Well, I can cool down while this is running. So the target temperatures for today are minus 140 on the CPU and minus 120, 140-ish on the memory. Yeah, so I think for Intel memory latency checker, I'm going to be... I could actually just take screenshots, I guess. Windows print screen if you want to quickly take a screenshot, by the way. Oh, you can't see the... Well, it's not negative yet, so... So this top temperature, that's the temperature of the memory sticks. And this is the temperature of the CPU. Man, Intel memory latency checker takes forever. I kind of wish it just gave you like, because the thing is what Intel memory latency checker is doing is it's testing the latency at a variety of different memory loads. So like it tests memory latency when you're, you know, pushing around 80 gigabytes of data per second, which is that first result, which is 72.38 nanoseconds, down to very low load as well. So yeah, at like 1.5 gigabytes per second, we get like 62 nanoseconds of latency. Apparently at 20 gigabytes per second, we got some very low latencies right there. That's interesting. Yeah. So there's like a optimum load level for this memory setup right now where it gets the best latency. Anyway, I'll just take a screenshot of that, and I'll only take the bottom result and the top result. So we're gonna take the like max load and minimum load. So that's 72.4, and minimum load is 62.34. And let's get to the actual overclocking. So we're going to restart, and we need to pull the temperatures down. There's not really much point trying to do anything until this is at minus 100-ish, so... yeah. So I think we're going to start with just 2T command rate initially. Also, I should have really thought about what a mess my desk is before trying to shoot this. Minus 13. Let's start with like relatively loose timings, because the interesting thing that I've noticed just sort of working with DDR5 on LN2 is that a lot of the memory latency reduction actually comes from just sheer memory speed as the memory controller clock goes up. So yeah, like having super tight primary timings doesn't necessarily translate into the lowest latency because you won't necessarily be able to clock the memory controller as high. And start at 48 on both of these, and 8. Actually... so I don't want to set these too tight, because I do want to try, like, high clocks first, so, yeah. And we're not going to touch those two. There we go. So, we're going to start with the 69-33 ratio. That one tends to work quite well. We can't change BCLK. Actually, I should be able to boot 7200. What are we at? Yeah, we're minus 45. That should work. So for that, we're going to want like 1 point... I think I'm just going to go 1.6 across the board and then VDD2 at like 1.55. tends to work pretty well on 1.35. So, by the way, if you don't know this, the CPU VDD-Q voltage on Gigabyte boards is actually hidden under the DRAM VDD/VDD-Q voltage, which is why I'm setting this to 1.35, even though I've set my memory voltages manually to 1.6. Yeah, it's weird Gigabyte BIOS things. Like, I don't know why they have that implemented this way. Anyway, I'm gonna just start at 6933 just to make sure that, you know, there's nothing wrong with it. Because 6933 with these settings pretty much has to work. Yep, that fires right up. So now we're just going to keep raising the memory ratio. See how far we can get. I think with this CPU, 7600 should be doable. Oh, 7200 fires right up. I think the CPU might not be cold enough, which is why it didn't train just now. The 3E54. Okay, I guess it's upset about something. And not just the temperature. The thing is, we can't change BCLK in the OS because IDA will break, so... And try that. The thing is, TRCD with cold memory generally goes really low compared to cast latency. Yeah, so cast latency was too low. That's 7400. I really want to try 7600. Like, that should work. Actually, we might be better off with slightly lower VDD2. And VDDQ as well. Like, DDR5 at low temperatures has some very strange behaviors. Like, for raw speed, if you don't care about performance, it's actually best to run kind of low voltages and then just get the RAM as cold as possible. And that's 7600 fired up, so yeah, now we're gonna see what we get in IDA. Oh, it's unstable? Not really seeing anything that immediately makes me think that this should be crashing, but... yeah, I'm not seeing any reason that it should be unstable right now, so I guess it might be just voltages. This will either get worse or better. I don't really want to make the CPU too cold unnecessarily, because then it will not boot. So I think that's actually worse right now. Because the preparing automatic recovery to that blue screen, I'm pretty sure the voltages are too high now. Yeah, they're too high. DDR5 thinks. Oh, and the BIOS crash, yeah. So I actually made it worse. Voltages are too high, way too high. Like, that's the really annoying thing with DDR5 is, like, you'd think, you know, the memory's at minus 100. 1.6 volts has to be, like, better than 1.5 or 1.45 or whatever, but not necessarily. Depending on the sticks and the CPU and the motherboard, sometimes the best voltage is like and the settings that you're going for, like sometimes 1.35 volts works better than literally any other voltage. Not that we're going to go to 1.35 right now, because I'd have to loosen out the timings for that, probably. At least this is good, like, practice for Geekbench, potentially. We're going to try 1.45. with 1.5. Oh, looks like it might be. Yeah, so it was upset about the voltages being too high. Man, DDR5 is so freaking weird. Like, it makes sense because the two voltages that I'm fiddling with, VDD2 is the memory controller, like the voltage the memory controller uses to talk to the RAM, and the memory VDDQ is the voltage that the memory uses to basically talk to the memory controller. Um, and so if they're too high, what ends up happening is the signal, or if they're too low, the signal being sent from the memory and from the memory controller will just end up getting really distorted, and neither end of the, like, the RAM and the memory controller basically won't be able to understand each other because one of them sends a 1 and it shows up and it's like, this looks like a 0. Anyway, let's hit idle latency. Yeah, so that's 52.7 nanoseconds. Not bad. Right? So that's 52.7. And that's at like 7600 CL36. I'm just going to rerun it just in case. And now we get 50.8, yeah. So IDA's not very consistent. Anyway, I do want to take a screenshot of this. Just as a sort of like have documentation type deal. Actually, we probably could drop TRCD at 7600, maybe not. Actually, I won't touch it. What did I want? Right, so we have... right, I also wanted the CPU-Z. This is unfortunately like an old version, but like we're not posting to hardware bot, so who cares? New Windows, why are you so stupid? There we go, and I'm just gonna have the main board and also memory. I was toying with the idea of using a different LN2 pot today, just so that the like temperatures would hold a bit more steady, but oh, come on. Okay, I guess I'm not getting that screenshot. That sucks. I wonder if the memory got too warm. I want to go faster. I know it did just crash, but like, I want speed. 1.4. So at this point, I think the cast latency might be a limiting factor. I'm going to set that to 8, just in case. It shouldn't really affect the latency benchmark. Oh, I think we might have socket contact issues. I was really lazy with the mounting hardware for today's session, and this whole like very quick 54 error, that's normally like that happens if you don't have enough mounting pressure. Or at least it tends to. Okay, well, we'll limp mode it, and maybe we'll try, like, lower speed, more volts, lower timings. See what happens then. Because, like, this memory kit should be able to do sub CL28. Or actually, we should be able to do CL28, but it just needs a ton of voltage. No, man, I really wanted 7600 to work. I have one more thing I really want to... I have a few more things I want to try. Oh, it trained. It might not be very stable, though. I really hope I don't have to, like, have good temperature control for this right now. Oh, I had to... Oh, no, it just passed again. Yeah, it's actually booting. Oh no, it got stuck on 4F. Oh, no, it won't start because it's at minus 4140. Yeah, okay, it retrains. Maybe it was the memory temperature. Like, I think if this gets into Windows, it's not going to run anything, but it would be cool to get into Windows. Okay, yeah, it's not going to make it. It's stuck on 55. It's right on the edge of being able to run, but I think I'll give up on this. And we'll try some 1T command rate, tight timing stuff instead. Yeah, like, the thing is, like, so with DDR5, we just need higher speeds. It'll be interesting to see if... The next thing I'm wondering about is, like, if the main limiting factor right now is, like, the memory controllers or the motherboard memory topologies. Because when you take the memory controller on LN2 like this, it actually gets a lot better, as you can see. Yeah, anyway, we're going to try... I'm going to start at 6933 for CL28, just because CL28 is very hard. We're going to try like 38, 38, 28, 44, 28. I'm going to go back down to 33.3, 1T command rate. 48. No, wait. Oops. Actually, at CL28, we should be able to set these even lower. I guess maybe I could have tried raising VCCSA at 7800, just because the memory controller clock would be getting kind of high at that point, but... Yeah, that fires right up. I've kind of spent most of my time at lower speeds with the Tachyon when benching, just because you don't have to fight the memory so hard. Like, speed is really difficult, because you need the memory controller to be happy, the memory to be happy, the, like... Whereas timings, you kind of get them for free. Like... It's not until you're, like, really going for a raw frequency attempt that you need to change the timings just to get a memory speed stable. Also, a 6933 is kind of really slow. So, previously, the best latency in IDA was, like, 50.8 nanoseconds. And now my expectations are actually kind of terrible. Like, I think it'll be worse. Because the memory controller clock is, like, way down. Actually, we're roughly saving that latency. 52.7 for the first run. Let's run it again. $53.2. Yeah, so I think this is probably worse. Which is what I'd expect. Like, contrary to popular belief, primary timings don't actually do that much. They look pretty. So yeah, CL28 slower than CL, what was it, 36? Because like the memory controller clock is just way down. Now obviously this isn't maxed out. I'm pretty sure we can do like 7200, maybe even more than that at CL28. But yeah, we'll see. Now let's run memory latency checker. You can see the memory temperature going up because the thermal transfer from the LN2 pot to the memory is kind of miserable. Yeah, so our like max memory load bandwidth is down by like 12 nanoseconds. So that's quite an improvement. I really wish I had gotten around to running memory latency checker at 7600. It's a shame it was so unstable. I feel like I need to spend more time, like, intentionally just working on, like, 2T command rate stability because, yeah, I've, like, basically so far I've been basically avoiding it. Even though 1T is actually just worse for, I think, all benchmarks. Like, if you can get the clocks high enough in 2T command rate, 2T is just faster. Because, again, like, I think probably the main limiting factor with DDR5 right now is the latency of the actual memory controller itself, not so much the memory sticks. Anyway, now we get a 45.8 in memory latency checker. So basically in memory latency checker across the board, it's like, so max load, we're down by like 12 nanoseconds. Minimum load, we're down by, previously it was 62, so 17 nanoseconds? Yeah, 17. So that's quite the improvement. Now let's see if I can get the clocks back up. Oh man, I missed the BIOS. You. We should be able to just go straight to 7200, I think. So you'll notice it didn't retrain, it just changed the ratio. So if the stability goes to hell, that's why. Oh boy, the mouse is freaking out. Where's Ida? $51.4. Still not beating that best, like the best result so far. Man, now I really wonder what it would have been in memory latency checker. It would have probably been like a 44 or something. Yeah, 51.6. Let's just run memory latency checker. Better. Actually, you know what? I'm going to cancel that run because I forgot to stretch the window. Well, at least you can tell it's running because the memory temperature is going up and there's LN2 in the memory pot. So now we're getting 57 for max load. I'm really tempted to just clock the CPU way up. Actually, we should do that. Just to show what kind of effect that has. So I will do that, yeah. So we get 44.63 now. Oh, first I want to see what kind of memory speed I can top out at in 1T command rate. 7400 should still be doable. Like, I am really bad at 2T. Because, like, going from 1T to 2T, you would really expect a bigger improvement than, like, 200 megabits per second. And, yet, like, that's basically what I get, is like 200 megabits per second. Okay, so that did retrain. And it's still stable. That's cool. Yeah, so I suck at 2T. Like, really badly. Like, there's people doing, like, 8,000 on 2T command rate, and then there's me. Ida's still not happy. Ida sucks. Like, admittedly, I did loosen out the TRCD timing, so... Oh, there we go. Under 50 nanoseconds at last. But we can do better. Because we can... Oh, wait, I didn't set the on-the-fly memory timings. Anyway, let's see. Intel memory latency checker. And I'm going to go grab more liquid nitrogen. Now I wonder what, like, the Comet Lake memory controller would get in latency checker. Yeah, so now we're under 44 nanoseconds. Because I'm pretty sure, like, I've actually got an IDA latency on Comet Lake as low as, like, 29 nanoseconds? Something like that? When I was on LN2. So... Yeah, I think, like, Intel... memory latency checker would have probably been at, what, like 25 or something? Anyway, so 7400 works. Kind of tempted to just go straight for 7600. Because why not? And we also want to turn this on, so that I can... wait, that's memory frequency. We don't need that. Memory timing mode dynamic there. Yeah, I didn't really expect that to work. 7600 is kind of tough. Yeah. It's not booting. Not booted. So, kind of tempted to just try drop the command ray and see what happens. Oh, it just trains. Great. Though I wonder how stable it'll be. Because with this much voltage previously, it was rather upset. So. Like, I'm not sure if it'll make it into Windows. And this time we're just going straight for memory latency checker. Because we've already run IDA at 7600 once. Latency. Run. It's definitely running. Oh, great, 55. Well, 56 nanoseconds, but still. We're down by 16 nanoseconds at this point for full max load latency. Kind of tempted to run Geekbench. We're running Geekbench. I want to know. $43. Now, 43. Yeah. So that's really low. Let's see what IDA says. I think I might have overshot it on the temperature of the CPU. If it goes any colder, it's likely to lose stability. $52.5. Man, IDA is so inconsistent. Yeah, 50.6. It also breaks if you change the BCLK, which is really frustrating. $51.7. Man, this is such a terrible benchmark. $49.3. Yeah, okay. Fine. I'm happy. Sub 50 nanosecond IDA. I didn't want to run Geekbench. Like, I really want to see what memory score we're gonna get. Kind of a waste of nitrogen, because Geekbench does run a bit hot. At the same time, the CPU isn't clocked that high, so the power consumption should be too high. It's just 5 gigahertz. Yeah, now here come the big, heavy multi-core tests. SFFT and DFFT. And N-body. Actually, I have a suspicion that... Well, no, I've had N-body crash on a bunch of times. Hey, 15,000! Right now, for LN2, I think the, like... A really good score on LN2 is like 16K plus. So, this isn't great. Like, you can get like mid... Like, I can get over 14,000 is doable on, like, ambient cooling. So, yeah, and I think there's people who are doing, like, mid 14,000s, like 14,500-ish or more on ambient, so it's not that great. Maybe 7,800? Like, I'd really like to get to run 7,800. That would be cool. So, let's see. Well, it didn't retrain this time, so... Oh, no, it is retraining. Oh, I guess it's because I have the timing mode dynamic. Well, it did train, though, so that's cool. And it crashed. Yeah. Oh, it's too cold again. I limp moded it at minus 138, but it's fine. I'm gonna grab more nitrogen, and I do want to... Now I'm kind of regretting that I didn't use the good operating system. Because I think this might be the best settings that I have run for Geekbench in terms of memory. So now if I clock the CPU up, I might be able to beat my old best Geekbench score. And it's up and running again. Well, it trains, so I'm kind of wondering... Maybe more system agent voltage. Because the thing is, like, it boots up and then it crashes. Now, admittedly, I don't know, maybe it's crashing because of the memory, but... Kind of tempted to... Because the thing is, when you're running low timings, that's primarily affected by the VDD voltage. And I don't really want to mess with the data queue voltages, that being the VDD2 and VDDQ. Because, like, we've got, like, apparently the signaling is fine-ish. Maybe. We'll see, I guess. Yeah, no, now it's upset about something. No, it does train. Okay, maybe it wasn't cold enough? Man, this is such a fiddly platform. Well, yeah, it's very fiddly to run this. Okay, it did boot. Please be stable. Oh, I think it crashed. Yeah, it crashed. Okay. So maybe less signal voltage? So, like, raising the VCCSA apparently didn't help. 1.45? At least it didn't retrain, so now we're gonna know if, like, we're gonna know very quickly if it helped or not. No, it didn't. No, I'm kind of happy with that, though. I'm not very, like... I strongly recommend that you don't have a 300 millivolt gap between your VDD and your VDDQ. This is a bad idea. We're on LN2, so I'm not too worried about it, but, like, I would not, like, definitely do not try to run your memory like this. Because technically the VDD and, like, VDD and VDDQ should be relatively close together for reliability reasons. So having a 300 millivolt gap between them, not exactly ideal. Kind of tempted to try lower VDD. Oh, and now it's very upset. I think this is kind of the end. I'm not sure that I can get 7800 to run. Kind of tempted to just try more VCCSA and... Oh, it doesn't go above 2. Okay, well, let's see if that helps. My original plan was that the video would be 30 minutes. I make terrible plans. I didn't think I'd get distracted by minimizing memory latency. Yeah, it's still upset. I'm kind of tempted to try to loosen out the primaries now. Because, like, I'm running out of, like, I don't think fiddling with the voltages anymore is going to do anything at this point. Like, it doesn't seem to be doing anything, so... 30? Now it's failing to train. No, no. Maybe? It booted, and I think... Yeah, it's not... Okay, well, now that I've loosened out the primaries, I should be able to lower the voltages. So I guess we'll mess with that. 1.6. 1.5. It's a bit more stable. Actually, it's a lot more stable. Like, the fact that we can get this, I mean, it did eventually crash, but that is a lot more stable. So maybe even less. Maybe even less voltage. And why is DDR5 so weird? Well, to be fair, it's not the only memory standard that has, like, a pretty hard voltage sweet spot. It's just... like, it changes depending on what you're trying to do. That's really annoying. Oh, man, we got all the way to the restart screen. Oh, but it's... yeah. Okay, less voltage again. $1.45? Like, at least I'm learning something here. It got stuck on 61. I don't know if that's, like, because it's super unstable, or... now it got stuck on 69. So now I'm thinking, like, the voltage is too low now. Yeah, because it just gets stuck on random things. Like, voltage too high, it boots up, but it crashes. Voltage too low, it doesn't boot. Okay, I guess I'll loosen out the timings again. Because that's sort of the main source of, like, needing a lot of voltage in my experience so far. Because when I did a max frequency attempt, I literally ended up with all of my voltages at 1.35. Well, that's not helping. I'm kind of wondering if MaxMem would have helped with the blue screens. So many things to test. Okay, so that doesn't work. What about 1.5? Once this thermos runs, like if this doesn't work on this thermos, this is over. Because, I don't want to, like, waste any more LN2 on this. I have other things I want to run on LN2, so... Can't use it all on, like, bad memory settings with 12th gen. And now it just doesn't train at all. Are you kidding me? You know, I'm kind of tempted to just try raw frequency settings. Or, which actually would be 40, 48, 48, auto, and then just auto everything else. I still don't get why the default right-to-right delay is so loose. Like, it is incredibly loose, and I have no idea why. Like, it defaults to, like, 26 or something. Okay, everything's good. There's also a chance that the memory's not cold enough, but... Like, there's people who've done 8,000 on ambient, so... We'll see, I guess. Okay, no, that's not booting. The 2E error is like... That's like, it's just not working. Actually, can I get this? Yeah, 2E is basically big fail. Wait, what? Why is it training now? It actually might be kind of interesting to see what kind of latency we get with just, like, really loose timings. And just raw speed. Though I don't think this will survive memory latency checker. Assuming we even get into Windows. Like, it's managing to train now, so that's some progress. I don't think the RAM's cold enough. Because the last time I tried to go for max speed, like, I had the RAM all the way up. Well, I had it at, like, minus 160? Yeah, less, like, I had it below minus 160. So we're at minus 116 right now, so that might be an issue. Okay, I'm just going to limp mode at this point, because it should be warm enough to limp mode now. It is. I wonder if even looser, maybe. Like, I don't know, 56? Okay, it really doesn't like that. It just gets stuck on 31. Yeah, I don't think this is going to work. Okay, maybe even lower voltages? Like 1.3 on everything? One 1.3. Actually, I'm going to leave that one at 1.35. But, like, yeah, these two on 1.3 is what I'm thinking. Okay, so this might work because it did the 2E thing before. Yeah, like it just managed to train. I'm completely out of nitrogen. Okay, it's not stable again. Thirty-one, 34, 3E, 30. Yeah, like it basically gets through the whole boot up sequence and then it crashes. Oh, that's it then. So, yeah, I mean, like I was kind of expecting to get the results I got. So yeah, under 50 nanoseconds on DDR5, you need like 1T command rate at like 7400 or something. So, yeah. Unfortunately, I don't remember the results from the video. I'll have to go through it. Anyway, yeah, that's it. So, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And then I also have a Bandcamp where I post music. So if you'd like to check that out, there's a link to that in the description below as well. Yeah, any of those links, like if you choose to support me through any of those links, that it would be much appreciated, as they help out a lot with running the channel. And that's it for the video. So thanks for watching, and goodbye. Goodbye.